Can you see my screen?
Yes, sir. This is visible.
Cool. Hmm. See, suppose, so any classification problem you tell me, Angela, any classification problem, example, which you understand in real life, any classification problem. So you are part of which domain, where you are working, or you are researching, or you are a student? What's your background?
Sir, I am a research scholar in BGSUM itself. My
Okay, okay,
area is economics.
okay,
So for classification, I guess getting a loan or something like this will is also a type of loan model or
okay,
finan
loan, okay, okay.
yes, default
So
risk model.
very good, very good. So default model, maybe we should provide loan or not, provide loan or not,
Yes,
provide
yes,
loan or not. Okay, okay. So maybe I am transforming this default or not, then it will make sense as well. Default or not. So one customer, if I give loan, he or she will default or not. That is my business problem is okay. Hmm? Now,
yes, sir.
now I have 100 data for modeling. 100 is very less, but 100 we don't use. But just for the sake of simplicity, I'm explaining 100 data set. So there are x1, x2, x3 variables. Okay, x1, x2, x3 means the customers customer own a house or not. What is the occupation? How much salary the customer draw? What is the family size? How many dependents are there? Any previous default history? How many credit cards he had? How many loans he had taken in future? What is the status of those things? So everything can be included in x1, x2, x2, and x3 until and unless we can quantify this properly or mark label this properly. So x1, x2, x3, these are my independent variables. Now, y is my independent variable, which is default or not default, d or nd. Makes sense so far, Angela? This is my problem and this is my data. Okay.
Yes.
Okay, you told yes. Yes was very mild actually. Can you repeat? It is a yes
Yes,
or no?
yes, sir. This y, yes, sir. This
Okay.
y is the dependent variable.
Y is dependent
I
variable, which is
understood.
default or not default, and x1, x2, x3 are independent variable, which we can gather to,
Independent.
yeah, we repeat predict y. Okay, so we can, so this is a categorical variable. Then classification problem, we can use decision tree. Classification problem, we can use decision tree. We can use decision tree. Classification problem. So far it is clear. Now, now I have a test set of size 10 maybe. Test set of size 10. Test set of size 10 and training set of size 90. Okay, now maybe it's 2%, 20% maybe default, or 80% not default. So though test and train set will be stratified, so in 90 how many will be default and how many will be not default? 18 will be not default. Okay, 18 will be not default, and rest 72 will be, oh, my bad, the
Sir,
reverse,
opposite one.
opposite one, correct. So 72 will be not default, 18 will be default. And here in actual, it will be 8 and 2, right? This is ND, this is default, 8 and 2. Clear? Now, now Angela is creating a model and I am creating a model. Angela is creating a model and I am also creating a model. So, okay. So I am saying my prediction in the test set, my prediction is all default, all not default, all not default. And your confusion matrix is little different. So what you are doing, you are actually predicting these two correctly. So how many you are correctly predicting? Here you are correctly predicting 2. You are correctly predicting 5 maybe, or not 5. You are correctly predicting maybe, out of 8. You are correctly predicting maybe 6. 6. So now default, this is not default, and this is default, and this is again not default, this is default, and this is your actual, and this is your prediction. Okay, prediction. Hmm. Now the actual, this will be 2, then actual not default will be 8, this will be 2. Default will be, actual default will be 0, right? So here it will be 0. So you understood this? You created this model and I created this model. I
Yes, sir.
created, yeah, I created this model. I am saying that I am predicting all 80%, all 8, here 0, here 2, here 2. So ND default, ND default. This is actual, and this is prediction. Prediction, right? This is prediction. Now tell me which model is better, Saptarshi one or your one? Anybody, anyone else want to try?
Sir, the
The
first one.
second.
The second one is better. Second one is better. This one is better. This one is better. You are saying.
Sir, where the false positives and false negatives will be less, that is better.
So tell me which one. So it is not that complicated. Hmm. let's forget about confusion matrix. What is your objective? What is your objective?
To
Objective is default to predict default or not default and not default properly, right? So predicting default properly will automatically result in predicting not default properly, because default is a less number. Default has a less number of records, right? Default has a less number of records. If we can predict default correctly, then we can assure that we are predicting not default as well nearly correctly, nearly correct, right? Always you need to identify the important class. Important class of your classification model will be always the less amount, the class having lesser number of records, because that is a rare thing in our data set. So predicting that rare part is important, right? So you need to identify your important variable. So basically here, accuracy, what is the accuracy? Total number of correct prediction in here is 8. 6 plus 2, 8. The accuracy is 8 plus 2 diagonal sum divided by total 6 plus 2 plus 2. That means, sorry, 6 plus 2, that is 80%. And what is the accuracy here? 8 plus 0 divided by 8 plus 2 plus 2, again it is 80%. But here the important class I am not, actually I didn't build any model, I just randomly say that everything is not default, then I am automatically getting 80% accuracy out of that. So but this is not predicting any default, default which is my rare class. Then this model is of no use. This model is of no use, because we are not capturing the objective, we are not capturing the class which is important, which is rare, right? So how we are deciding that? Not only this accuracy will suffice, then we need to understand two things. First, step one, important step one, important class, default, important class. You can write down these steps, okay? This is very fundamental. Important class identification, that is your not default. Okay, now precision of important class, that is in denominator total number of predicted of prediction of important and correct prediction. What is correct prediction? 2. For Angela's case, it is 2, and total number of predicted important class. This is D. This is row. This row we should sum. That will be 4. 4. Then 50%. And what is the accuracy? What is the accuracy? Now the accuracy is 2 will be above, and we need to sum the row, right? Accuracy 0 plus 2, 0 plus 2, 100% accurate. Accuracy of, not even this accuracy of that particular class, important class, is called recall. In multi classes, for it is called recall, and you can term it for binary class, you can term it the sensitivity. I described this actually to you. Sensitivity. If it is multiple classes, for each and every class we need to see the accuracy, then we can term that as recall. Basically the funda is, you need to understand the important class, and accordingly we need to see whether your model is performing to detect the so first one is detect how many, what is the percentage of detection, and what is the percentage of correct prediction. Okay, so now I'll give you another scenario. I'll give you another scenario. So suppose another person, maybe Gaurav is creating a model, and that model is model look like, sorry, why I crossed this is correct model na? So Gaurav created another model. Actually he didn't create any model, he is saying all are default. Then what will happen, right? All are default. So if someone is saying all are default, then the bank will not provide loan to anyone, then the bank will not do any business, right? That cannot happen. So it should support business. If you are saying all default, then your your default class will get predicted correctly. So let me tell you. So all are default. That means how many we are correctly predicting? 2. How many we are not correctly predicting? That is 8. How many we are predicting not default? 0 and 0. See, NDD, ND, and D. See here precision. What is the precision, Angela, over here? Tell me. This is actual and this is prediction. What is the precision? Precision means total number of predicted will be below, and above it will be the correct prediction, right?
20%.
20%.
Accuracy.
20% is the precision, and accuracy is 100%. Accuracy is 100%, right? Accuracy for important class. 2 by 2, 2 by 2, 2
Yes,
plus
2
0 by
by
2,
2.
2. But this
2
model
plus
will be
0 by
of no use because of this precision. You need to see this together. You need to see these two values together. So the important class precision and important class accuracy. Accuracy means this sensitivity or recall. You need to see this together. If both are in acceptance range, then you can freeze your model. Okay, so otherwise, if we are saying everything not default, then your business will not support. Business will not get supported. If you are saying everything is not default, then your business will be at risk, and everyone, the business will start providing loan to everyone. That will be a risk. And another risk in practical sense, if you are saying everything is default, everyone will default, then business will not run because they will not be able to provide loan anyone. So we need to have something in between, right? Not everyone. So we need to have something between. We need to detect the fraudulent customers or the default customer accurately, more accurately. It will not be 100%. It is for an example, it is accurate. Okay, and we need to find out the default as much as possible. If you are saying one default and that is matching, then precision will be 100%. Let me show you another scenario. Why this sensitivity is also important. So now suppose now Soikat is creating a model, that model actual, not default, default, not default, default. Okay, this is prediction. Now, so we got this saying, so we got this predicting this one predicting one, rest are predicting predicting one correctly, one default correctly, and rest it is saying not default. So this is 8 and 1. 8 and 1, right? So now what is the precision? Precision will be 100%, 1 plus 0 by 0, 100% precision. So 100% precision doesn't mean 100% accurate as well, 100% recall as well. So 1 plus, so this will be 1 by 1 plus 1, that is 50%. 50%, then you are not unable to detect this fraud as well. If it is a huge number of 50% fraud, you are not detecting. Then this detection rate is very low, so you are only detecting one out of two. That is very important, which is very important. So basically we need to have high detection rate, that means high sensitivity or high recall, whatever terminology you want to remember. And we need to have a high precision as well. Whatever you are saying fraud, that should be nearly correct, that should be high, the percentage should be high among the prediction and among the actual. The correct percentage of the important class should be high, otherwise your business will suffer. So Angela, you understood?
Yes, sir.
Okay. So you just listen to this recording another time and think about the thing. So it might confusing you, but if you practice this 2 3 times, the things will be clear once and you will not never forget. Always your concept will be at top. Okay, you just listen to this recording another time and just practice the thought process. You think, you write the confusion matrix yourself, then that will be great. It's very easy, very easy, nothing, just counting. Okay then. So let's move to random forest. So again, this is ML, supervised, unsupervised, and reinforcement learning. In supervised, classification and regression. Here random forest classification, forest classifier, and here random forest regression, RF regression. Excuse me. So basically, random forest can be used in both scenarios, regression or and classification, both. Regression. Okay. So random forest. So any idea about random forest? So what it can be from the name, just from the name. Very easy to understand this random forest.
A lot of decision trees.
Lot of decision trees. It's a forest, right? Any other question? Yeah, other answer. Any other answer? Okay.
Randomly, we are creating,
Okay. Okay.
making the categories.
Okay. Okay. So first one, Sandeep answered, right? First one,
Yes, yes.
lot of decision trees. Very good. Randomly, what?
We are doing the stratification.
We are doing the stratification. Okay, let's not call it the stratification. Stratification is a different thing. So randomly we are sampling the data, to create trees, sampling the data to create this, create trees. Okay, any other thought on random forest? Any other thought? Anything coming into your mind, just let me know. So just fundamentally, I will try to explain something. Just you try to just yeah. I'm defining these two things. So machine learning is something which is supervised machine learning is something y equal to fx. Y equal to fx. Okay. So x1, x2, x3 can be there in fx. I am writing this as a vector. Multiple x can be there. So y equal to a supervised machine learning, right? Supervised ML. Now this f is a function which is relating y and x, y to x, right? Now, if f1, f2, f3, there are three machine learning. So same data, three machine learning models, y, y, y. Three machine learning models, f1, f2, f3. Okay. If they are predicting something, so they are independent. Basically, they are independent. Okay, they are independent. So this is very much practical. You will not get this in books, but this is a practical knowledge. So you should understand. So why? So these are independent and they are generating prediction, and we are combining the prediction somehow. Combining the prediction somehow.
So one thing I want to clear that the sample selection would be like equal proportion of variables, right?
May not be. I'm not going into that. The entire x family is there. All the variables are there. The columns, there can be different way of for different.
Maybe proportion can be or cannot be same, you're saying.
Cannot be. Anything can happen. So for different algorithm, different things. So fundamentally, this is a special kind of algorithm where this is a supervised ML. This y equal to fx is valid. Then this is a supervised model, but multiple functions which are independent and predictions are getting combined at the end. This kind of learning, this kind of model is called ensemble. This kind of learning is called ensemble. Okay. Now, here f1, f2, f3 are not connected. Now, I am writing this y equal to f of x, f1 of x. This is a different class I am defining. Y equal to f1 x. Hmm? X equal to f2 of different x dash equal to f3 of another different x. Now, can I write this? Y equal to f1 of f2 of f3 can I write this? Can I write this?
Yes.
I can write this, right? Because I am replacing x by first f1 x. So first it was
Yes.
f1 x. Now f3x is replaced by x dash, and this is the way, right? So now here, what is the difference between here and here? Left side and right side. What is the difference? So here also f1, f2, f3, it's a combined function. We can write it as f dash f star x or something f. We can terming that as fx, simple fx. fx. X is a transformation of x star, so it is interchangeable. Hmm. Fx. So basically this x, basically this fx formulation ensuring that this is also machine learning, right? And here also these formulations are there, f1x, f2x. This y equal to fx, fx definition is getting hold here. So that's why this is also ml. Okay, this is ensemble ml. And what is this? What is this? What is the depth of this function? Y equal to f1x. Depth means how many functions? One. What is the depth of this? This is
3.
this is 3, right? This is 3. What is the depth of this? This one? 1, right?
Yeah.
1. So there is a depth. There is a depth. The thing is deep. Deep. And the functions are connected to each other. One's input is another's output. Another's That's input is another's output. So the thing is deep. This particular kind of learning is called deep learning. Okay, so whenever you will be studying neural network is a deep learning model. It's not ensemble. Random forest is an ensemble. It's a deep learning. Neural network is a deep learning model because the functions are connected. Hmm. Is it clear for everyone? This is very fundamental thing. Please answer.
So can you please
Yes.
repeat your last sentence? So you're saying that random forest is a deep learning.
Random forest is not in deep learning. It's in ensemble. Again,
Okay.
let me tell this another time. Okay, it will help.
No, I mean just the names. Was
Ah,
actually
for the names only. See, so supervised ML. This is called y equal to fx. Now y1 equal to f1x. Now let me take y, only y. Otherwise it will be confusing. F1x, y equal to f2x, y equal to f3x. We are combining the prediction combined. Huh? These are called ensemble learning. Ensemble learning, what are the examples? Ensemble learnings are bagging. Okay, bagging, let's not. Random forest, combine. Ensemble learning examples are random forest, mm, boosting, gradient boosting, grad boost, ADA boost. Different kind of blend models are there, blend, stack. These techniques are falling under ensemble learning. Okay. Now nomenclature is clear. Naming convention. These are independent. Is it clear?
yes. So what's under this grad boost? Is
Gradient
it
boosting. Gradient boosting.
no gradient boost under gradient boost? What you have written?
ADA boost.
ADA boost. Okay.
ADA boost. ADA boost, logic boost, cat boost. There are a lot of boosting techniques are there. Very popular.
So basically, boosting is generally you're saying the
Ensemble.
ensemble learning.
Ensemble learning. Right. Correct. And here you are connect. So y equal to f1 of f2 of f3 x. Again, the functional relationship is there. Na? This is a function, combined function, but it is a function. So it's a ML, and there is a depth of dependency. That's why it is called deep learning. Examples: feed forward neural network, recurrent neural network. In the recurrent neural network, there can be LSTM, GRU, gated recurrent unit, transformers. Transformers is highly used in image cutting edge image processing, image analytics, and computer vision basically, and in NLP, natural language processing. Transformers are getting used nowadays. Not nowadays. It's from last 2 years. So LSTM, okay, LSTM and GRU. Okay, these are the examples. These are called deep learning models. These are deep learning models. Okay, now though you have the fundamental clear, now what random forest does? It's very easy. Okay, so here is your data. What it does, random forest, how? It's your training data, and it's your test data. So training data have huh? Just I'm coming. Just give me a moment. Okay, sorry. Yeah, sorry, I'm back. So x1, x2, x3, and this is y. Okay, this is my training set, this is my test set. Now tree 1, I am creating tree 1 randomly. I am picking randomly two columns, x1, x2, and I am taking two rows, row 1 or maybe 3 rows. This is my data set, and I am creating a decision tree, and it is looks like this. This is my decision tree. Now tree 2, again I am taking x1, x2, and x3 randomly. Columns are, and I am taking rows, maybe other rows, some other rows. This is row number 10, this is row number 11, this is row number 19, this is maybe row number 3, row number 19, row number 4. Okay, so again I am creating a decision tree, which looks like this. It's a small one maybe. Okay, tree 3.
And by this, you're saying that not necessarily we have to have all the variables in
Yes,
each tree.
it's not, but you can control from outside. If you don't need that column level sample, then you can control from outside. Okay.
Okay.
Okay. So this is 19. So this number of rows may be more. Okay, number of rows may be more. 19, 20, 21, 30, 100. These are the rows it is taking. These are the taking. Everything is normal, randomly. Okay, this is randomly, and these trees can have rows in common. Okay, as you see, 19 is present in both T1, T2, and T3. Doesn't matter. So maybe it's a large tree. Okay.
And one small question, I mean, so
Yeah. So
is it necessary to have at least one common column between all the trees, or I mean, there could be totally independent trees? I mean, so one is built on x1, x2, x3, the
no,
other one is
totally
x3,
independent.
x4, x5, x6.
No, totally independent. It is taking randomly. So we don't have only consider 3 columns. That's why there are something in common, but they may not be. It is randomly.
Okay, so there may not be any common columns between
Yes,
these trees at all.
that's right.
Okay.
I will take a pause, and you tell me if you have any question. Okay, out of this, out of that, what the first step is, we are taking the training set and we are creating multiple trees. That number of trees we can declare. Till now, any question you have, just let me know. Just think about this and let me know. Write in your own pen and paper and let me know. This is very important. After that, I will move into something else. Now, next step. Any question? No question then. Okay. Now, these trees, so during creating these trees, what they are doing? They are splitting this training data is for tree 3, right? This is a training data, small training data which is randomly sampled. Here it is creating 80-20% sample. With 80% it is creating a small tree and testing on 20% for accuracy, right? And finally, if accuracy is good, it is reaching to this tree. Okay. Here as well, this is a small training set for this, and it is doing a train test split here as well. This is train, this is test split as well. Okay, and it is creating model, small model using this and testing on this and testing on this, test on this, and this is train, and finally it is reaching to this decision tree. Similarly for this as well, right? What it is doing. So basically what we learned in decision tree section, it is doing in each and every step, each and every, for each and every random sample, it is creating that, following that that procedure. It is creating a automatically creating a test training set and test set and testing the performance of the tree on the test set. Okay. So in every, so there is a terminology, every test set, so every, these are called bags, these are called bags, bags of data, these are called bags. So after this bag, after creating this bag, we are creating a training bag, and this, keeping this bag, these 20 examples out of that training bag, training bag. So that's why this particular test set is called out of bag samples, OOB samples. And after testing this, the accuracy is called OOB error. OOB error. The performance measurement is OOB error. It is nothing but 1 minus accuracy. OOB error, out of bag error. Based on this out of bag error, random forest will fix whether this tree is good or not. Because if we are creating 1000 tree, in 1000 trees, that out of bag error for 500 or 600 trees, the out of bag error is very high. If out of bag error is very high, they are just not considering those 600 trees in the next step. They are only proceeding with rest 400, where the OOB is low. The error, OOB error is low, maybe to maybe 20%, 10%. If it is 90% error, then that will hamper my prediction, my next step, na. So that is very common. So suppose in tree 1, we are getting OOB error as 18%. Okay. Here we are getting in tree 2, it is getting 53%. And in tree tree 3, we are getting 5% error. So
Sorry,
whether
can you please repeat? I mean, so bags, I understood that, okay, these are bags. So what is out of bag
out of
sample?
bag, okay, the training set is training sample is training bag, and
Okay,
the test set is out of bag.
test sim. Okay,
Yeah,
test set
these
is.
are the terminologies used in different blogs, different books. So the things are same, nothing fancy.
Okay.
Okay, so if you see this terminology, what is OOB error? Now you will get confused. OB error is nothing but that same confusion matrix. You have to sum the diagonal and divide by total and subtract that from 1. That's it.
Okay. And the performance or the Gini which we check. So this is at an overall bag level, or I mean,
No. For each and every decision tree.
okay, for
Not
each and
overall.
every.
Nothing is overall. Everything is independent.
No. So I mean, so yeah, that's what I'm saying. So we not look for the nodal performance here. We will look at the overall performance of a tree.
Again. So decision tree always we also saw we are not seeing nodal performance there. Decision tree during splitting it is seeing Gini and all, and accordingly it is splitting. That is already happening here.
Okay, that is already happening. Okay.
That is already happening, and at the end we were testing now. You guys calculated the accuracy. I show the confusion matrix. So the similarly it is calculating automatically. It is calculating within random forest the error of
Okay.
the model. What if the error is high? It is discarding that particular tree. They will not use that tree. If the error is low, then it is keeping that tree.
Fine.
Like this. It is 80% low, 53% high, and 5%. So in the next step, we will be moving with only T1 and T3.
Okay.
T1 and T3. Maybe let me add another tree, which will be accept. Let me add another. There is a tree 4 maybe. There is a tree 4 as well with OB error maybe 5%. Okay. Then we are considering this T1, T3, and T4 we are taking in next step. So far, any question? Okay. Now, now I have T1, T1, T3, and T4, and this is my random forest model. Random forest model, right? Now, how will I test my random forest model? That is something we need to generate prediction out of this. Now, how we can generate prediction and combine that? This generating prediction and combining is might be different for different models. Okay, so for random forest, what it is called? It is called voting. It is called voting for classification. Voting for classification, and for continuous it MAPE we see we based on 3 trees we can do some weighted average. Okay, so let's not confuse ourselves. So there will be different trees for continuous variables, and from the prediction we can simply take a weighted average, and where weight will be the proportion of the data. Okay, for now let's consider voting. Let's consider this for continuous one, categorical one, voting. So now I have a test set. You remember before starting I kept 20% as test set. It's a different test set overall. The training data was there. From the training data we created this random forest T1, T2, T3, and T4. And but at the beginning we had a test data which was 20% or 10%, maybe 10% test data. In 10% test data, so suppose there are 5 records, 1 2 3 4 5, 5 records, and models. How many trees are there? T1, so 20%, so 10% data, 10% test data. Now 10% test data, 1 2 3 4 5, maybe my 5, and we have T1, T2, and T3. Okay, and this is my actual. Suppose I am doing a binary classification, 1 or 0. So this is lone default 1 1, now 0 0 0. Okay, now this is actual. Okay, now T1 is predicting 1. This is 1, this is 0 0 0 0 0 1 0 0 0 0 0 1 1 1 0. for 4. Okay. So now what will be the voted prediction from this first one? Voting prediction, voting rate. That is the prediction from random forest. You vote that two trees are saying 1 and one is 0. Majority is 2. Okay. Now here two trees are saying 0. Then the oh, majority is 1. Then the voting prediction will be 1, not 2. And 0, 0, 1. 2 are 0 and 1 is, so again 0 is winning. Here 0 is winning for the third. For the fifth, 0 is again winning. For the sixth, 1 is winning. Right? Now this is my prediction. We have generated from these three, this and this, and this is my actual. Now tell me what is the accuracy total. All over accuracy is first one is correct, second one is wrong, third one is correct, fourth one is correct, fifth one is wrong. So 3 by 5, right? 3 by 5 is one. That means 60% is my accuracy. Okay. Precision sensitivity for 1 and 0, that will be different, definitely. So just overall accuracy I'm saying. Okay, this is entirely, this is random forest. This is something we know, we call as random forest, because randomly trees are getting generated. Okay. So any question on this? So I took a continuous example for random forest so that you can have the diversification, and your homework will be to create random forest on the data we use for decision tree. That will be your homework. Hmm? Any question so far? No. Then let's open the code of random forest. Let's open the code for random forest. Someone, I closed this. Sorry. Yeah. So this is the random forest code. Please open and let me know. I am waiting for your response. Please drop me a message. Tell me verbally anything. Just open this code in like you open decision tree code.
Yeah, open for me.
Okay. Others. So attendance is very low. How many students you are? 1, 2, 3, 4 only are left. Anyways, you already know these things. You guys already know these things.
No.
You do you didn't know, right? These things.
No, no, we did not.
Okay, okay. Yeah. Anyways, that's fine. So this is a code. So this is the code. To import, you can import pandas and features. This is features. Yeah. So now year month. So we are predicting. I think the temperature is getting predicted, or what is the y variable over here? Mm, Feature list index average. This average it is creating. Temperature average. This It is actually considering as y. Hmm. Okay, now here is a level. Here we are dropping. Here we are dropping over here from here. Hmm. And 5 head. So this is something, this is a categorical variable. It is introduced, it is getting introduced into dummies. So you go through the code and let me know where you have questions. Okay. Let's do this practice. You go through the code and let me know. So here we are reading the data so far, and up to this point where you are actually not understanding, just let me know. Okay. So do you know how you can use categorical variable in a model? So x is categorical here, right? Here this day, month, week, these are categorical variable, right? Day, month, week. So specifically week. If week is important, we can consider this week. We can consider this week. So suppose we have a categorical variable, maybe grade, grade A B C, A B. Okay, A B C. So this tree. So how we can take this as the input in random forest model? That is our decision tree model maybe. So for decision tree, we don't need to make these changes. Decision tree automatically changes that. So we need to make we need to transfer this column into different columns. Maybe grade A, yes, no, or 1 0, 1 0. That means if it is grade A, then it will be 1, else it will be 0. Now grade B, again 1 0. So this one, how we can take this?
We need to change all variables in the decision tree to 1-0 binary.
No, not this. This is for categorical variable. As I told, this is for categorical variable input in random forest in Python scalar.
Okay, okay.
Okay, we need to do this. So whatever is not continuous, it will automatically convert into categorical. Hmm. So you need to declare that whatever is categorical using dummies function, you can convert this. So this grade is ABC ABC. So grade A 1 0, B grade B, first one will be 0, right? Because it's not B. Second one will be 1, then it will be 0 again, it will be 0 again, it will be 0 again, then it will be B, it will be 1, right? And now automatically, if this is 1, this is 0, then the C will be 0. So we don't need that, need to create any column for C. We don't need to create any column for C. Am I right? We don't need this. Basically these two are explaining that.
Yes.
Hmm. So this particular thing for our treatment for categorical variable is called one hot encoding. One hot encoding. One hot encoding. That is something getting happened over here. That is something getting happened over here. This
Sorry,
one.
I didn't get this well. So
Okay. Okay. So this one you got this one you got or no?
No, I mean, so why
Okay.
we don't need grade C is what I'm still
Yeah,
guessing.
yeah. Okay, okay, okay. Why we don't need grade C? So now these two are these two columns. So if you have three levels, if you know two levels, then that will be suffice. That will suffice, na? So this 1 0, what will be the value of grade C? You don't need to look into this. You don't need to look into the grade column. You can automatically say only one is there. Maximum one can be there, na?
Okay,
Maximum and
so
at least and at
for
most
that,
one can be there in the rows. That information. So basically, otherwise these three columns will be multicollinear. So two columns are explaining another column. So that's
okay,
why
basically
always
from that collinearity sense you're saying.
yes, correct.
Okay, okay, yeah.
Collinearity.
So what is it called? So you're saying that grade C would either be collinear to grade A or B.
So A, B, and C will be collinear, will be linearly dependent. Those three both, those all three. Because C can be explained in this way, na? C can be explained C
Mhm.
column, grade C column
Yeah,
is
so
called
grade C can either be explained by grade A or grade B as well.
alpha into grade A column, B column plus beta into A column. So this linear combination can be written. So then that will be linearly related. Understood?
I'm still absorbing. So my earlier thought was also, I mean, so if we have like grade A, B, and C,
Okay. You need to take all. That's what you knew.
so this is the so these are these are the inputs to model, right? I mean, the independent variables.
Yeah, these are inputs to model, but
Yes,
they should not be dependent
they
among
should
each other.
not be dependent. Yes.
If we are taking grade C, you can input that in the model, but they will become dependent of each other. Okay, that this is unnecessary information for the model. So
Mhm.
if this is 1, this is 0, obviously grade C will be 0. This is 0, this is 1, obviously grade C will be 0. This is 2 0, obviously grade C will be 1. You don't need to see this. You don't need to see grade
So
column.
I mean, this is what I was not understanding. So if it's 0 0, why it's obvious that grade C would be 1?
Obviously your grade, yeah, obviously in your grade column you have total 3 levels. 2 levels are not, then obviously the rest.
Okay, because
There are three
okay,
levels.
maybe so I understand collinearity. Maybe this specific example is what I'm not able to absorb.
Yeah. Let me give you another one example. Okay. Hmm. So suppose there is a tournament. In tournament A, B, and C, these three teams are playing. Okay.
Okay.
Okay. Player one. I am giving a one information from player one. Player one not belong to A, not A, and not B, not B.
Okay. Yeah.
Now I am asking which team the player one belongs. Can you answer?
C C C C.
Obviously. Now player two, not
Okay.
B, not B. Now can you answer specifically which team?
No, either A or C.
Either A or C. That means you cannot specifically answer.
Mhm.
At least we need more information. Not C or not C or yes, not C. Now you can answer.
Yes. A.
So these columns are basically explaining other column.
And how these are related to the variables which we have or the independent variables which we have in data.
Ha. Okay, so you may have age group as an independent variable. So age group you need to, so in random forest or in gradient boosting you need to create numerical matrix for age group. So in age group 10 to 30,
Mhm.
30 to 60, 60 plus, 60 plus.
Okay.
Okay, so we cannot define the distance between them. We cannot define the distance between them. So we can define but there is a natural order, but we don't want that to be considered. So these three groups are there. So obviously we are not going to convert this to numeric. We will create three columns: if 10 to 31, or 30 to 60, then 1 or 0, or 60 plus 1 or 0. But if 10 to 30, 30 to 60, these are, and 60 plus, these are only my options, then we can take two, any two. The rest will be automatic.
Okay. Okay, so basically you're saying that using two groups, we can
Ah,
determine the
ah.
third one.
So the formula empirical concept is, so whenever you have a categorical variable with n labels, you should have n minus 1 columns after one hot encoding. OHE. This is something you need to follow. So in some packages, automatically one label, it removes automatically one label. In some automatically remove one label. In some of the packages, it doesn't remove. So you need to be little careful that it is removing the extra column. Otherwise, your model will result in multicollinearity effect. It will be exposed to multicollinearity effect. Bad
What is
effect of
this OHE?
oh, one hot encoding. Oh, sorry, I shouldn't write
One
that.
hot encoding.
One hot
Encoding.
encoding. This is the term.
Okay.
One hot encoding. One hot
So
encoding.
is it, I mean, this one hot encoding is there or not depends on Python version or?
No, 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 no. It doesn't. Different libraries are there. You need to check carefully whether one hot encoding it is removing the one column at least or not.
Okay, so
Otherwise,
it's just the dimension thing which we have to check, you're saying.
yeah, 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 yeah. Okay. So now this is something we have. Hmm. Now this is where we are actually basically importing the model and all model and stuff. So this is the label np array features actual. Okay, features drop actual. We are dropping the actual from the feature set. Feature set means all the columns. We are taking it. So this is my actual. This is my label. This is my y variable, and this is my features. We are dropping the actual column from there. Now feature list is this, and features are converted into np array features. Okay, numpy arrays, and after that we are splitting the train and test. Train features, test features, train labels, test labels differently. Okay, so we are seeing the size here after running this, and here, so this is my, the baseline predictions are historical average. So this is simple average of the history, average from the history. This is the baseline prediction. Okay, so baseline errors minus test levels. So now see, this is where we are running the model. Random forest regression in estimators, random state 42. Okay, so this is where we are initiating the model, and after that we are fitting the model. Fitting, what is the input? The input is train feature, and input is train feature and train levels. N estimators mean in 1000 trees, 1000 decision trees. Okay, in that manner. So you can define max depth, you can define the termination accuracy. Many parameters are there in random forest. Okay, you can easily get get those things in SQL and documentation for random forest. So you are fitting the random forest over here, and after that you are predicting the features. Hmm? You are predicting the features, and after that you are getting the mean absolute error. Mean absolute error is something which is percentage is something which we will discuss for continuous variables. So this is a continuous variable prediction, right? We are predicting the average of this temperature 1 and temperature 2. So let's discuss how we can calculate the accuracy for continuous variables. Hmm. So we have categorical, we had categorical variable. Categorical variable, how we measure the performance using confusion matrix. For classification, for performance measurement, for classification, performance measurement, we can use confusion matrix. And for regression means continuous predictor. Continuous, not predictor, continuous dependent variable. Regression, what we are using here is called mean absolute percentage error. Okay. Now see, I'll define this mean absolute percentage error. This is useful for time series as well. Okay. Mean absolute percentage error. So now this is my actual may be 100 and prediction may be this. Actual may be 125, this may be 120. Actual may be 500, actual may be 10, this can be 9. Okay. So now let's say these are three values in your test set. Okay. Now what is the error? Absolute error. Absolute error means, so 100 minus 50 modulus, absolute error. That means 50, absolute error. 50 is my absolute error over here. Error. What is the error here? So maybe this prediction, let me change this prediction a little bit. This prediction is maybe 11. Okay. Now what is the absolute error over here in second value? It is 5, right? 125 5 plus minus 20, 5. And what is the absolute error over here? Anyone can answer?
1.
1, because it is minus 1 modulus 1, right? Okay. So absolute percentage error, 50 by 100, error, absolute error divided by actual. Here it will be 5 by 125. Here it will be 1 by 10. Okay. And absolute percentage error, it's if we take its mean, simple average, mean of these all values are called mean absolute percentage error, MAPE. That is how we can judge random forest regression. Okay. Any question in this? Okay, just think about this and let me know if you have any question. I'll take a pause for another minute. Angela, any question?
No, sir. Not from here.
Okay. Okay, so next I will just discuss one important concept, and after that we can have a closure of this class. So let me explain cross validation in classification. Okay, so this is something we have mean absolute percentage error. We can do some cross validation, like cross validation in classification primarily. Okay. So we discussed cross validation previously. So you are creating a model. You are creating a model using your data. This is your training data. You are creating a model. This particular model, this is a training data. Suppose the training data is of size 900, 1000 rows, 1000 records. Okay, records. Now you are creating a training data and test data, training and test, and what you are doing, we are creating the model on this, and predicting the accuracy. Maybe precision and sensitivity are 77%, and sensitivity for one, the important class, is 80%. And you are passing the model, and in the production it is failing miserably. Like it is showing 33% sensitivity and 40% accuracy, 40% precision. So what happened actually? Why we got this 77% and 80% in this test set? That might happen because of the sample problem in the sample. That might happen due to problem in the sample problem. That particular sample, for that particular, see, everything is random. Everything is random. So this thing, this we are stratifying, but sample is random. So randomly a sample which is coming, which is very good to predict, and it is providing high accuracy. Okay, high performance measure. But in actually it is very low. It is low and fluctuating. So that's why, to avoid this kind of scenario in production, what we should do, we need to test multiple times with multiple samples. So what is the way? We have 1000 samples. We are defining k-fold cross validation, here k equal to 10. Okay, k equal to 10. So now what we are doing? So we are dividing the entire data set into 100 samples. 100 samples. 100 samples. So this is 1, this is 2, this is 3, this is 4, up to this is 10. Now I am creating my model 1. Model 1. After creating the model, testing and training and testing, you are seeing that your model is accurate, then you should do this cross validation. This is the next step. So for model 1, another model. So this is another model. After completion, you completed random forest creation, you completed decision tree creation, and you are seeing that 80% and 20% accuracy. Then you do this process, cross validation. So now you are creating 10 samples. In M1, sample 1 is test, 2 to 9 is train. Print the accuracy. Maybe accuracies are 70% and 81%. 81% is my this is my sensitivity, this is my precision. Okay. Now M2, 2 is test, 1 and 3 to not 9, this is 10, right? 10 sample. 3 to 10 is train. We are lefting behind 2 now, the second part, second 100. Now I am seeing that this is 71% and this is 82% sensitivity and precision. Okay. Now M3 is 3 is in test set, 1, 2 and 4 to 10. 4 to 10, these are train set. We are noting that 70% and precision is 83%, and so on. And so on. We are testing M3, M4, 4 will be left out, rest will be training. In 5, M5. So in that manner, we are creating 10 models, and we are predicting every time we are printing, after calculating the accuracy on the test set, We are predicting the sensitivity and precision. Okay, now sensitivity and precision will be, sensitivity and precision will be a 10, there will be 10 numbers, right, for sensitivity, for M1, M2, M3 up to M10. Now if this is suppose sensitivity S1, this is P1, S2 P2, S3 P3. Okay, so this should be close enough. This S1, S2, S3 up to S10 should be close enough. It cannot be S1 is 92% and S2 is 60%. 60%. It cannot be. If there is this kind of cases, very frequent cases, and S3 is maybe maybe 32%. Then you straight away reject the model. Your model is not built. You need to rework. But if it is stable, so 80 to 85, it is varying between 80 to 85 or 75 to 80, then you can say at least this is reliable, stable. Okay, so this, how can we measure that? Using standard deviation. We can take standard deviation of S1, S2, up to S10, or we can just observe and decide as well whether this is stable or not. Similarly for P10, it should be stable enough. If it is stable, then the standard deviation should be low. This is called cross validation. This is called cross validation. Okay, just think about this and let me know if you have any question. I will take a pause.
So what I have in my mind is, I mean, it depends on what model we are talking about, and then we decide that if we have to see precision or if we have to consider recall. So, I mean, there could be models in which we can see both of them, and as you've said, uh, like, so based on if both are comparable, we can do a cross validation. And also, I mean, so if we see that, okay, recall is fine, but then there is some issue with precision. So how we, I mean, what should be our approach and how we deal with that?
Basically, you are asking that different kind of scenario may arise, then how we should decide, right?
No, so I mean, see, cross validation, we mean that, I mean, that okay, our model is able to predict the output well or not, right?
Mm-hmm.
This is the cross validation.
Mm-hmm.
So in which I mean, so you've considered both precision and recall.
Yes.
Okay, but
Of the
then
important class.
no, sorry.
Of the important class in binary classification. Of the important class.
Yeah, even in binary classification. So what I think is it depends on model, that if we should consider recall or precision, there could
No.
be models in which both we can look for. But then I give you an example. So for example, that if there is a model which predict that if it's a malignant cancer or not.
Okay.
Okay, so we are more keen to see, I mean, what's the sensitivity or what's the recall?
Yes.
Because
yes.
then, I mean, if we miss a malignant cancer, so that
Yeah.
would be very lethal. So we are not supposed to miss that occurrence. So true
Correct. That's
positive
why.
is something which matters to us
Yeah.
out of the total true positive and false negative,
Hmm.
right? So their precision is not that important. So from that perspective, I was saying.
Precision is important. Why I should say. I'll
So
say.
even if it's a false positive, I mean, so
Yeah.
things would not go lethal. And
Yeah.
that's the reason I'm
But
saying that
it
precision
will
is.
not go lethal. But one thing, there will be harassment of the patient. You understand? So
So this is the secondary thing. So
yeah.
I mean, I was just giving you an example that this is one model in which I consider that recall is a major thing to look for.
Yeah, recall is major thing to look, but recall is not only major thing to look, because if I say everyone is malignant, then you will not able to understand whether my model is correct. I didn't create any model. I am just saying everyone is malignant. Whatever you are sending me patient, I am saying malignant. Then always what you are doing, your sample. So you are getting a sample which is indeterministic, right? There is nothing, no information, because all patients I am saying malignant. Then it will not make any sense. But your accuracy will be 100%. Accuracy, that recall will be 100%. So only recall is not sufficing your goal. You need to see how many, what is the correct prediction percentage. That means precision as well in mind. So suppose, so out of 100 malignant patient, I am detecting 92, which is very good. I am detecting 92, which is very good, 92%. But someone else who created a model, he is predicting 100%. Now I did a deep dive. I am saying that out of 1000 patients, he is saying everyone is malignant.
But then this has two two levels, right? So one is accuracy. So if we have an impressive accuracy, that's fine. But then apart from that accuracy, at the second level, this precision and recall comes. So
Yes,
we say that okay, accuracy we are
yes.
fine with it. It's very good. But then what's the sensitivity of the model? So that is something which matter here.
No, 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 not only that. That is what I am trying to explain. Not only that, sensitivity can be. I can. So see, so how many malignant patients? Suppose 100 malignant. I'll let you understand. Just give me a moment. But maybe you have 100 samples, 900 non. Actually, 900 non-malignant
Mhm.
and 100 malignant. Okay. I am creating a model and you are creating a model. I am creating a model and Gaurav is creating a model. Okay. Now you are saying only malignant, predicting malignant will be important. Now I am saying. Okay. Now, so this is malignant, non-malignant. This is malignant, non-malignant.
Yes.
I am saying everyone is malignant. Okay. So that means 100 is here. This is prediction and I am providing 900 here. And this is 0, this is 0. Right. This is my model. I didn't create any model, but I am just providing this prediction. Everyone is malignant. Now Gaurav created a model. So same, this is actual, okay, actual, and this is prediction. This is actual, this is prediction.
Okay.
So malignant, non-malignant, malignant, non-malignant. Now Gaurav, you created a model. You are predicting 90%, 90,
Okay.
or you are predicting maybe 98, maybe 98. Okay, two cases are going out. Two cases are going out, and here
And then
98
two.
cases malignant. Then you are predicting maybe 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 150 or 110, maybe another 12. Okay, and here 98 prediction, and here actual malignant will be 2, and here it will be the rest. How many it will be? 900 minus 12, right?
Yes.
900 minus 12 means 888.
880.
888.
888.
Yeah, now see, suppose the insurance company or the medical treatment for, so the one medicine, so for some decision, finding out the possible malignant patient, some medicine has been rolled out for them. That is the decision the business is taking. So one medicine cost maybe 100 rupees. One medicine may cost 100 rupees. So here how many, from my model, 100 into 1000, this is something the cost is getting incurred.
Yes.
Huh? And for your case, how many?
98 into 1000.
Not 98. 98 plus, sorry sir, no, my bad, 100 is the cost. And how many you are predicting?
So 98 plus 12 is
100,
I'm saying malignant.
110.
110.
110. So
Yes.
where cost is low?
So, but you are predicting 1000 into 100. Okay, fine. So cost is low for my
Yeah,
model.
yeah, that's the problem. Here, sensitivity, if we report sensitivity only, sensitivity is here 100%. But precision is
Yeah.
0. This is not make any sense. If I only see at sensitivity, model might
I
model
think
might give me some,
precision is also 1 for or 100% for you, right?
yeah, precision, no, precision is 10%. Total prediction, how, what is precision? What is precision? Precision is 10%. If you see precision, you will get to know what is the problem. With sensitivity only, you will not see this problem. Precision is, you you understand, right? Precision is 100, divided by total predicted malignant. 10% precision. And your 100
Precision is 100 divided by 100 divided by
100 plus
100, no?
900.
I mean, it's true positive and false positive.
Don't,
So
don't go to true positive, false positive and all. It will confuse you. So just think how I am saying. So you see, total predicted. How many you predicted as malignant? You tell me.
no, but then precision. I mean, the denominator would not be 1000, right?
Why?
For precision, we say that
how,
okay, out
how,
of
no. Listen to me. How? Let me.
out of total prediction, what is the true prediction? Is what precision is.
Out of total prediction, how many?
Out of total prediction of malignant, right? So we are saying that okay, 100 you predicted that 100 are malignant. Then there are
No. Go up. Just hold on. That's what I am saying. How many I am predicting malignant? 1000, and these are wrong. 900 is wrong.
So 900 is non-malignant. But okay, sorry. Yeah, actually, I'm reading it incorrectly. So accuracy is at left hand side. Okay,
then 100.
Yeah.
Prediction. This is prediction.
Sorry. Yes. I was wrong. So I was reading it wrong.
And that actual is an accuracy, the sensitivity, whatever you are saying.
Yes.
Sensitivity is very good. Sensitivity, how many total actual malignant is 100? 100.
Yeah.
Sensitivity is better than you. Does
Exactly.
that mean my model is correct? No. You need to see precision. Otherwise, you will proceed with the false information and you will incur a large amount of cost. The cost is playing a role. You get my point? These two together, they are important. Together.
No, well, that's for sure. But I mean, the kind of model. So you've created a pricing model, right? Which medical the pharmaceutical company would look into, or maybe the insurance company would look into. So the model which was in my mind is from a doctor's perspective. So if a doctor has a model, and then
but
he has to see.
will the doctor so everywhere cost is involved. If 1000 patients are suddenly come, how many cancers doctor you have? The doctor, you will not be able to provide treatment. You will be providing treatment to some non-malignant cases and ignoring some actual acute cases. There is a cost as well. You are saying which is humani, as a human, sentimentally that is wrong, because sentimentally these two patients are getting penalized in your model.
Yes.
Sentimentally, ethically, but that is how the real world is. You need to look into the objective, which one is efficient. I need to look into the time as well.
So for cross validation, what would be the final outcome we should consider? Maybe let's consider your example.
Sensitivity and precision both should be stable. And precision you can live with. For these cases you can live with 50% precision, maybe 50% precision.
So what are the thresholds generally?
That depends on your business. That
depends. Okay.
Well.
That is subjective.
This is prediction. Now I'm coming into your point. I'm supporting you now. Default, not default. Default, not default. This model is humanitarily it will be better. So I am why?
No, I mean I understand. So whatever the model is, so
malignant, non-malignant.
Yes.
Non-malignant, non-malignant. I'll tell you. So in malignant, I'm saying 100. I'm predicting 200 as malignant. And here, so non-malignant, this will be 800. And this will be 100. This will be 0, right? 0. Now accuracy is 100%. That means
100%.
sensitivity, not accuracy. Sensitivity is how much? 100 by 100 plus 0.
Yes.
And specificity, not specificity. Precision will be, tell me, what will be the precision?
So precision will be 100 by 200. Sorry, 1000.
Yeah, you are right. 200. You are right.
Yes.
Now 50% precision. Now this.
So where is this 800 number coming from? 800 is a non-malignant, which is the
non
prediction,
with
and
which
okay,
is a
actual is also
correct.
non-malignant. Okay, yeah.
So now this you can decide your precision level, but there should be at least some precision. Otherwise, your cost will be huge.
Yeah, okay.
Both are important. Both are important.
So there are no thresholds, you're saying? It's very much subjective
It's
based
very much
on what you
subjective
want
to
to
the
see.
business, to the tolerance of your business. Correct.
Okay.
You need to understand the objective. Based on that, you need to decide. But these
Okay.
two are important equally. No less, no more. If you are seeing one and are ignoring other, you might get into trouble. The model might get into trouble.
Yes.
So hope I made sense now.
Yeah,
Okay?
many thanks. Yes.
Okay. Okay. Yeah. And thanks for bringing this up. Whoever understood this, it's a very fundamental thing they already cleared. Okay. Then looks like people got dropped. So your home, I'm giving you some homework. Okay. Giving you some homework. Can you just reply? Gaurav, can you do me a favor?
Sure, sure. Yes.
Yeah, the favor is you need to circulate this homework in the same email chain I shared the document with.
Sure.
Okay.
Yeah.
So number one, use decision tree data for random forest to create cross validation for both decision tree classifier and random forest classifier. Just email this that I provided as homework. That's it.
Okay.
You will remember, or I should send this to you?
No, I have noted this down.
Okay, okay. Create cross validation for both decision tree classifier. You need to mention. Otherwise, there will cross validation for the continuous variable will be little bit tricky. So sometime
Yes.
later I will tell how we can cross validate continuous variables as well.
Okay.
Okay, same trick can be applied. Here map should be stabilized. Map, many absolute percentage error should be stabilized.
Yes.
Okay then. Okay then. Thank you. Thanks everyone. If you don't have any other question, you may drop off.
Thank you.
Thank you.
Okay. Thank you.
Sir,
Yeah. Tell me, Angela.
yes, we learned about this random forest cross validation for the continuous variable, right?
Come again. Come again.
We learned about this random forest techniques.
For continuous variable, correct. Purposefully,
Yes,
I took that because I was about to give you this homework.
okay.
Okay.
So we learned about this voting, weighted, and all on
Yeah. For
cross validation.
yeah. And similarly for regression as well, it is a weighted average of the prediction of different trees. Trees are predicting some continuous variable, it will be a weighted average. So in case of continuous categorical variable, it will be voting 1 1 1 0, then it will be 1 majority, and for continuous variable it will be a weighted average. So suppose first model is predicting 10, second model is predicting 20, third model is predicting 30. So and first model data amount of data in first model is maybe first model is predicting, first model have 20 data, second model have 30 data points during training, third model has 40 data points, and this is predicting as 5 6 5. Then the final prediction will be 20 into 5 plus 30 into 6 plus 40 into 5. Okay.
Sir,
And divided by 20 plus 30 plus 40. 30 plus 40. This is a weighted average. Let's not think that complicatedly. It will be a weighted average of these three predictions. That's it. Yeah, tell me.
Research perspectives from economics. I- Can there be any like website or any reference where I can like connect these models with the economics and understand it in a
With economics, so maybe you need to define your business problems, what you want to predict and what will be your x variables, then you can connect.
okay. Mostly then financial parts these are available, but
Mm-hmm.
for other
See, this is
economic
there is
problems,
a branch of economics, there is a branch of economics where we learned economic tricks. It is called
yeah,
econometrics.
yeah, 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 yeah. So mostly I was aware with linear regression,
Yeah.
then the errors and the econometric modeling part,
Mm-hmm.
and a bit of time series.
Mm-hmm.
So this is different. Like so, I just wanted to know if there can be some connection and I can relate it because I have more idea about this autocorrelation, heteroscedasticity,
Mm-hmm.
this part of econometrics. But this email and AI, if there is any reference material which can be connected from the point of economics,
From the
it will be
point of
very
economics, yeah, from point of
yeah,
economics. See,
yeah.
fundamentally two things. So everything can. So fundamentally, if you are forecast, so time series is a different thing. Okay, time series. Let's not discuss time series. Let me tell you. Let me stop the recording then. Just give me a moment.